Okay, here we go. We want to write 4i in polar form. 4i in polar form. Don't write on your iPad with a marker. Okay.
It would come on.
I don't want to find out. So what is my R value?
R equals modulus.
What does R stand for? R is the...
Modulus.
Yes. R is the modulus, which is really just the distance from 0. It's just your radius. I don't like it being called modulus. It's just like the hypotenuse. So if you think about this, 4i would graph where? It would be on the imaginary axis at 4. So what's the distance from here to here?
Imaginary.
That's on the imaginary axis, it's 4. So this is my modulus. It's 4. So this is 4. Which one's the imaginary part?
Where do we get sine from?
Because it's on
Oh,
Y.
because it's Y. Because I saw
For
I like the answers like that.
Theta's brother.
What about Brutus?
Theta's brother Mu Alpha. No.
A2 was that? Is that from
It's
Brutus?
theta. But he thinks Mu Alpha spells math.
Mr. Coots, why is that mu alpha theta? Is it because it spells math?
I have.
Again,
Well,
I'm going to have to double check myself. I'm not feeling great about this being correct, but I think I'm doing it correct. Here,
it's math.
what is R equal to here? It'll be the square root of, go away Siri, the square root of negative 4 squared plus 4 squared, which is 16 plus 16, which is radical 32, which is 4 radical 2.
The second one, the negative 4 plus 4. I think.
Okay. Now, I think I messed up the last one because I think I know what to do on this one. So let's keep working this one. I need to find my theta. So think about this for a second with me. If I go to negative 4, 4, that puts me here. What would be my reference angle?
Negative
Negative
4.
4, would it not be?
It would be above.
Yeah, sorry. My apologies. Thank you. Thank you. Negative 4, 4 would be here. Right? Left and up. What's my reference angle? If I went 4, 4.
45 degrees.
It's 45 degrees. Which means how much did I rotate to get 45 degrees in the second quadrant? 135, which is 3 pi over 4. It's 4, 4, 4 radical 2. So this would be 4 radical 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4.
That's the answer.
I think so. I'm going to go double check that. And then we're going to go fix the one above it because I screwed it up. In the problem before it. We found the radius correctly, but I need to know my theta. How much did I rotate to get here? 90, which is pi over 2. So my answer should be 4 times cosine of pi over 2 plus I sine of pi over 2. What is cosine of pi over 2, though?
90 degrees.
It's not 90.
Oh, I was thinking.
Pi over 2 is 90. What is cosine of 90? 0.
0.
Which means, really, this part we could ignore. It could just be 4I sine of pi over 2. Right? Here, do you guys want to try this one without me? Or do you want me to do it? You need to know your radius. You need to find theta.
Okay.
See if you can do it without me. Okay. You ready for me to do this one? Or you need a little more time? No, go. Okay, let's just go. So on the real axis, we should be at radical 3, which means I went over radical 3 on the right. On the imaginary axis, we went up 1, which means I'm looking for this distance. This is the triangle that we know. It's 1, radical 3, 2, which means what should be my angle here? 30 degrees. Opposite of 30 is a 1. So that means for me, R is 2. Theta is pi over 6. So this is 2 times sine, there's a cosine. Cosine of pi over 6 plus I sine of pi over 6. Or you could write 2 cis pi over 6. Now we're given polar and we want to convert to rectangular. What is cosine of pi over 6? Pi over 6 is 30. What is cosine of 30? This is radical 3 over 2. Plus I. What is sine of pi over 6? And then the 12's out front, right? So this is 12 radical 3 over 2 plus 12 times I times a half. We'll just simplify this. What's 12 over 2? What's 12 times a half? Is it okay with that? Hey, so you know, all right, what's different here? It doesn't give me theta. But it gives me tangent of theta. So could we find theta from this information? How? If tangent of theta is 5 over 12, how could I find out what theta is? I need to isolate theta. Not square roots. Inverse tangent. Or arctangent of both sides. Theta equals, what's the inverse tangent of 5 over 12? Make sure you are in radians.
Why did we start with tangent again?
It's all, that stuff doesn't go away. I told you that in Unit 1.
Why don't we do an arctangent in 3/9?
0.39. Give me 3 decimals. 0.395. On the AP exam, you had to round to 3 decimals, so let's just start getting ready for that. Always to 3.
What did we do? I'm so lost.
I found theta because it didn't give me theta.
Oh, we used inverse tangent.
So I took
of
inverse
12.
tangent of 5 over 12 to find theta. Now, I can write the polar form now. Polar form would be 13 times cosine of 0.395 plus I sine of 0.395.
So it's cis.
This goes 395.
So now I have to distribute. So what is 13 times cosine of 0.395?
13 times cosine of
It's actually,
Almost.
actually you didn't have to find all the theta now that I think about it.
It's almost 12.
Go ahead. Type that in, see what you get.
11.99895534. So 11.999.
12.
Basically 12. Plus,
I thought we rounded 3 decimals.
we do.
I put the actual.
What is 13 times sine of 0.395? It's not 1.
5.
Oh, let's get into it.
So all my inverse tangent was useless. Because what did this tell me?
Rise over run.
It told me the opposite was 5, which means I went up 5. The adjacent was 12, meaning I went over 12. Well, which way is over? That's the real axis. So the real part was 12. How much did I go up? I went up 5. That was the imaginary axis. I didn't think of that. That's on me. Until we started getting to there.
12.
So 5, 12, 13. The Pythagorean triple. That's one of them that I know. I'm not lying on that one. It's not that interesting. So if I have a complex number, r cosine theta plus I sine theta. Hey,
No, it would
I
probably be
can't right now.
instead.
Let's see, Luke's.
Hydrogen plus
But he
bond
lived
equals-
before
I'll
this
go get
guy.
him.
Yeah.
I'll get him in a second. But I can't right now. They're testing right now.
Dini plus Dini plus
equals-
that.
Okay.
Yeah.
Yeah, I will. I mean, as soon as I get home, I'll go do it. Alright.
What about 3?
Okay, this is my complex number in polar form. Well, if I raise it to the nth power, I can just raise the r to the nth power, multiply n inside here. Right? Or here's the form. If I know what the nth power is, n goes here, n goes there. If you write in that form. So, here's the bottom line. If I want to know what 1 plus I to the 5th is, I just need to find where is 1 plus I. We just ignore the 5th power. And then at the end, we come back and put the 5th power here and here. Right? That's all I have to do. So, we're going to convert this, which is in rectangular form, to polar form. So what's the real part? 1. What's the imaginary part? 1. Do we know what r would be? What's the radius of a 1 and 1? Radical 2. So 1, 1, radical 2. What's my theta? What would be my reference angle here? 45 degrees, which would be pi over 4 in radians. Which means for 1 plus I, that form would be radical 2 times cosine of pi over 4 plus I times sine of pi over 4. Is everybody okay with this? This is what 1 plus I is. But now we want to know what is 1 plus I to the 5th. So now we raise this to the 5th. And we multiply this by 5 and this by 5. That's De Moivre's theorem. So this is radical 2 to the 5th, which we can write as 2 to the 5/2 times cosine of 5 pi over 4 plus I sine of 5 pi over 4. Or we could just write it as 2 to the 5/2 cis 5 pi over 4. Okay with that? We just ignore the power and then just put it here with a radius or the modular, whatever, modulus, and put it there, multiply by theta. Okay, let's go ahead and get started. This last unit is on vectors. And I've never watched Despicable Me, so I don't know. But there's a guy named
You've never
Vector.
watched
Magnitude and direction.
That's the deal. That's what vectors are. Vectors have magnitude and direction. All that means is magnitude means it has a distance.
He creates a.
That's the distance of our line segment. Direction means we hear where it's pointing. Think about polar. What's polar all about? Polar's about
The piranha launcher.
the magnitude. Polar's about how far the radius of the circle is. That's my magnitude. And the direction, where I'm pointing. What's my theta? Okay, that's all this is. It's just now we're calling it something else. If you go into physics classes, this is the way they talk. Is magnitudes and directions. Magnitudes typically use V or U in bold, or whenever we write them by hand, we'll write U with a ray over it. Do you guys know what a ray is?
It's
Like a line, but only on one side. Half a line.
Yeah.
Okay? That's a vector. Because vectors are rays. They start at the origin, and then they go in one direction. Right? So,
We're not Maroon 5.
so here we go. Consider the vector V. The vector V has coordinates of 3 and 4. This is 3 in the x direction, 4 in the y direction. This is a directed line segment that extends from the origin to the point 3, 4. That's what we want. It went right 3, it went up 4. This version of a vector is called the component form. So when you see this, this is called component form. 3 is the horizontal component, x-axis. 4 is the vertical component, the y-axis.
Actually, the imaginary.
So here's what that would look like, just to make sure we're all on the same page. It starts at 0, 0. It went right 3. It went up 4. Here's the point 3, 4. Here would be my vector.
It's like a never-ending hypotenuse.
Kind of. What's the magnitude of this vector?
3 times 4.
The magnitude.
Well, I went right 3. I went up 4. What do you guys think the magnitude is?
Theta.
5. It's the distance of that vector. It's a 3, 4, 5.
Oh, it's right about.
How could I find the direction? Direction is just this theta. Well, tangent of that theta is 4 over 3, which means theta is the inverse tangent of 4 over 3. But there's the formula. Y over x.
Wait, does that say X or 3 at the bottom?
X, and this is y.
This is so sissy.
Oh, I thought that was.
Y over x, which is 4 over 3.
Wait, Coach Coots.
Yes.
Why
Yes.
do I have an extra piece of paper?
You probably just forgot to staple it.
One of them maybe didn't stay in.
I had 2 stations. And one of them was
Yeah,
one
some of
page.
them were messed up. So I may not have caught your mess up. Count your page numbers at the bottom. You have a 9 to 10?
No.
Then that's yours. It just didn't staple.
Oh, that's great.
Here you go.
That's one more paper for me to keep back here.
I had 2 that messed up the first page, so I caught those and I stapled them.
Sunday morning, the rain.
Are we good? Can we rock and roll? Rock and roll, rock and roll. Thanks. All right. The first one here is just drawing the vector. In component form, the vector should be -5, 4. Which means what? This vector starts at the origin. It goes left 5. It goes up 4. This is the point, -5, 4. This will be my vector. Just a ray. Starting at the origin, ending at -5, 4.
So how is it a ray? I thought a ray is half a line.
This is a ray. It is.
Yeah, but if it keeps going past
It-
5, 4,
That's its initial. Don't get into that. It does go in that direction forever.
We learned this in elementary.
That is not starting at the origin. Right? They could start anywhere. And then we can always move it to the origin. And vectors are the same. Let me go through this real quick. from here, say from here to here, is a vector. If I went from here to here,
Is it also a vector?
it's the same vector. If it has the same magnitude and the same direction, it's the same vector, no matter where it starts.
Is the magnitude the size?
Yes, it's its distance, it's its size. Yes. So I tried to make these, they're not quite. I tried to make them the same magnitude, the same direction.
Those are parallel.
They're the same.
Parallel
They look
vectors.
parallel. That means they're the same direction if they're parallel. And then the same length means they have the same magnitude. So we're going to take this vector that's out in space and we're going to move it to start at the origin. It's going to be the same vector, it's just starting somewhere different. So let's set this up. We've got point A is at -2, -4, which is here. And then we have B, which is at 3, 1, which is here. It tells me, look how it's vector AB with a ray. You see that? That means we start at A, we end at B. That's important because direction matters, right? Even though this would have the same magnitude, it has the opposite direction. Right? So we have to keep it going from A to B. And this one was A, this one was B. So I'm looking for the magnitude.
Oh, so we have to do like.
So I need to figure out how far right did I go? How far up did I go? How far right did I go? I went from -2 to 3, which means I went right 5. How far up did I go? From -4 to 1.
3.
That's still 5.
5, radical 10.
That means this one is 5 radical 2. It's a 45, 45, 90. If you weren't sure, you could do the Pythagorean theorem, right, to find the third side. But it's a 45, 45, 90.
Yeah, that's a Pythagorean triple right there.
Which means what would this angle be? 45 degrees?
Yes.
So this is AB in its original form. Now what would be its component form in the standard position? That means what if I took that purple line and moved it to make it start here? I want to keep it with the same direction, which means this angle is still 45, and its distance should still be 5 radical 2, which means how far right did I go? If I start 5, how far up did I go? Which means what's the component form?
5, 5. Component form is like the new spot.
This is component form, where it looks like an ordered pair, but you do those weird arrows instead of parentheses. This just means it's a vector. Yeah, whatever, alligators.
Vector.
2 vectors are equal if they share blank and blank.
Vector, magnitude and direction.
Magnitude and direction.
Yeah. Right here? Yes.
Here we go. Oh, it's called Rainsville National.
Could be. Should be.
TPC Rainsville?
The magnitude of a vector is its length. Did y'all know that? The magnitude of a vector is its length. I talked about that at this
Yeah.
point, so hopefully we get that down by now.
Why does vector say that?
Consider the vector. Consider the vector v, which is in component form xy. The magnitude of v is written like this. What does that remind you of?
Vector.
Absolute value.
Absolute value of the vector. What did we just learn in the last one? Absolute value is the distance from 0. It's all the same. I mean, these are all intertwined. They're just different applications of the same math over and over. So what is it? The magnitude is just the Pythagorean theorem, right?
R squared equals.
So what's the magnitude of this vector, b, that has components of -15 and 20? How could I find the magnitude?
Go over 15,
Uh-huh.
up 20.
Uh-huh. Negative 15 squared plus 20 squared, which is 25. This is a 3, 4, 5 Pythagorean triple, but every side has been multiplied by 5. 3 times 5 is 15. 4 times 5 is 20, which means 5 times 5 is... See how those Pythagorean triples can make your
So we got 15.
math much quicker? It's a 15, 20, 25, which is just a 3, 4, 5 stretched by 5.
I like that.
25.
From here,
6, 16, 20.
what would be the magnitude of this vector? I know what it is. I don't have to do the math. Can anybody tell what this one is? It's not 1. What kind of triangle is this?
4 up to. Oh,
It's 45, 45, 9.
It's 45, 45, 90.
It's a 4, 4, 4 radical 2.
4 radical 2. That's right. Boom! If you didn't know that, Pythagorean theorem, right? 4 squared plus negative 4 squared. 16 plus 16 is 32. The square root of 32 is 4 radical 2.
Or, I just remembered the last
Yes.
one. It was 5, 5, 5 radical 2.
Yes. Share this with you. Wanting to make a unit vector. Okay? What's a unit circle?
A circle.
Unit circle.
It's 5 radical 2.
A unit circle is centered at the origin with a radius of 1. Because its magnitude, its radius was 1. Well, guess what a unit vector is? It's a vector whose magnitude is 1. So we're going to find what the magnitude of the original vector is, and say the magnitude was 10. Well, then I need to scale that down by 1/10, because 10 times 1/10 makes its magnitude 1. So that's all this is. To find my unit vector, I take the vector that was given to me, and I'm going to multiply it by 1 over its magnitude. That shrinks it down to give me a magnitude of 1. Here's what that looks like. Okay, so I guess I'm just going to make this up. If this was my vector, I'm just going to say these are the points 3 and 4. All right? So I'm at 3, 4, 5. A unit vector would keep the same direction, but it's going to be like, normally this has a distance of 5, right? But my new one's going to have a distance of 1. Right? That's what it looks like. Does that make enough sense? Keeps the same direction, just changing the magnitude.
So we need to find out what 3 and 4 would be if the radius was 1.
We would it'd be 3 over 5. That's exactly correct. This would be at 3 over 5, 4 over 5. Because I just multiplied those components by 1 over the original magnitude. Right? So right here is my original vector. This vector is got components of 6 and 8. So what would be the magnitude of this vector? $10. It's a 3, 4, 5 that's been doubled. Or you could do the Pythagorean theorem, right, to find 10. Either way, you find it. So,
That's times 2.
huh?
Because 3 times 2 is 6 and 4 times 3 is 8.
Oh. Okay. So.
So this is vector V.
Oh, okay.
So to find vector U, we need to multiply by 1 over the magnitude of V times vector V. Right, this is the very formal way it looks. If you ever take other classes, that's the way it looks. Here's all that means. My original vector was what? 6 and 8. My magnitude is 10. So this is really just 1/10 times, this is 6 and this is 8. Right, that's my original. So what's 1/10 times 6? That would be 6/10, which is
0.6.
3/5. And 8/10. That's it. Unit vector. It tells me to draw them both. Do I have to draw those? Do we understand the premise? I'm taking 6/8, this big vector had a magnitude of 10, and I'm keeping it shaped the same way, but shrinking it down to a magnitude of 1.
But we already.
Okay. Any vector component form can be written as a linear combination of I and j. So, if I write this, does everybody know what this is? Component form of 3, 4. I could also write this as 3i plus 4j. And my teacher that I had in college, he wrote them as I hat and j hat, so that's still the way I write them. That lets me know it's a vector and not an imaginary I. Don't get confused.
Wait, what?
I just took 3, 4, and I just wrote it as 3i plus 4j.
Oh, okay.
It's the same thing.
But he draws them with a hat, so he doesn't.
So I don't think that's imaginary.
Yeah.
It's not the imaginary I. This is a vector part, I. It's just another form. Just like how we had a real part and an imaginary part in the complex plane, we have an x part of a vector, and we have a y part. Component is the right word. X component and y component. We can just write them with I and j.
We, after since you
Do some of the stuff without some of this.
Okay. Are you ready? Was that simple enough? Like I went through that fast, but I think it's very repetitive. Like it's nothing new. Here we're going to get, I told you vectors, if you go into the physics side of things, that's where you're going to get a lot of vectors. So this is a physics problem if I've ever seen one. Noah pulls with a force of 75 pounds on a wagon handle at an angle of 30 degrees above the horizon. Resolve this force vector into vertical and horizontal components. It's not bad, all right? I know when you read that, but just think how cool this is, that you're like basically doing physics right now. So, if he pulled his wagon handle horizontally, it would be here, right? That's the horizontal. But he didn't pull it horizontally. He pulled it 30 degrees above the horizontal. So here is the pull on the wagon handle, right? Say that if you want to draw this out, here's the wagon handle. Here's my wagon. That's terrible. Just ignore that part. Okay, I can't draw. If you had a real good drawer, they might. But just imagine, here's his hand on the handle. It's right here. At 30 degrees above the horizontal. How much force did he pull with?
75.
75 pounds. That's the magnitude. The force you pull with is the magnitude. This vector has a magnitude of 75.
I remember vector saying force in the
So now I just need to convert this or resolve this into its components, which means I want to know how far on the x-axis did this go, how far on the y-axis did this go.
So we use law of sine, maybe?
You don't have to do the law of sines. We could just do, for me to find y, what do I know? I know this angle. I know this side. Well, what's the relationship with this angle? This is opposite. This is hypotenuse. Which trig function deals with opposite and hypotenuse?
Sine.
So sine of 30 equals opposite over hypotenuse. What is sine of 30? It's a half. So that means 2y equals 75, which means y equals 37 and a half.
So,
This is y. Sorry, I put it on x. Is it okay with that? How can I find x? You got options. You can do trig again. You can do cosine of 30.
We already know 37.5.
Or you already know two sides.
Law of sine.
You could. Let's
Pythagorean theorem.
Pythagorean theorem would be the easier one here. I know two sides of a right triangle. I could find the third side using the Pythagorean theorem.
I guess you're right.
What?
I don't care which way you choose. Right? They'll all give you the same thing. You could use law signs. That's not exactly. I don't. Well, then you do it. Then go ahead. Who's going to do the Pythagorean theorem?
Me.
Go for it. I'm going to do cosine. So we'll all do something different. No, not law of cosine. I was going to say cosine of 30 equals x over 75. So cosine of 30 is radical 3 over 2 equals x over 75, which would be 2x equals 75 radical 3, which means x equals 75 radical 3 over 2.
I don't think I'm doing this right, but I'll figure it out eventually.
75 radical 3 over 2 is 64.95.
Oh, so 65.
That's what you get.
Hey, I did do it right.
If you do the Pythagorean theorem, you would just get 64.95. You wouldn't get this pretty. Like, I like that better. This is me personally.
Who did that?
Me, I did it as cosine. I said cosine of the angle is the adjacent over the hypotenuse.
Wait,
And I solved.
I did 75 son 30 and got 37.5. On my calculator.
Yours should be sine of 30 over 37.5 equals sine of 60 over x. So you should do 37.5 times sine of 30 divided by sine of 60. Is that what you have?
I got sine of 30 over 37.5 equals sine of 60 over. Oh yeah.
Over y over x.
Equals sine 60.
Okay, here we go. An airplane's westward velocity. Okay, which way's west?
This way.
It's actually that way.
Yeah, but on our two-dimensional plane, this way's going to be west. So an airplane travels with westward velocity of 200 miles an hour. So in this direction, it's going 200. Its northward velocity is 150 miles per hour. And just going northwards at 150. What's the speed of the airplane? It's not 200.
It is.
It's going west 200 and north 150. Means it's going here. This is the way it's going.
Okay.
So what's its actual speed?
250.
Yes.
That's a Pythagorean triple.
Yes, it's a 3, 4, 5 Pythagorean triple. 150, 200, 250. If you didn't know it, you could use the Pythagorean theorem to find the missing side.
Or you can just know it.
I agree. So what's the speed? The speed is 250. Speed is just the absolute value of the magnitude. Okay? So speed 250 miles per hour. What about its direction? I don't remember how they want me to answer this. I think I'm going to remember.
Northwest.
I think it's going to be that west of north of, remember all the Sasquatch stuff. But I need to find this angle. Right? That's the angle I'm looking for. So it would be the inverse tangent of y over x, but my x is negative. I don't think it's going to matter. I wouldn't put in the negative if I were you. I would just put in 150 over 200. It's going to be the same thing, just one's positive, one's negative. For us, I would take the positive one. Are you in radians?
Yeah.
Go to degrees. I think this is going to want degrees.
36.87.
36.87 degrees. Is it okay with that? So I don't know how they're going to want you to answer this. I think they're going to want 36.87. This is due west because we're touching west, right? So I need to go 36.87 north of west. So 36.87 north of west. I think it's how that wants to be answered. If it's not, the only other way you could answer this will be how much did I rotate to get 36.87? Well, that would be 180 minus 36.87. Right? I mean, it's just back to the unit circle stuff. But if I remember correctly, I think it wants it that way without me having the answer right here. So, here we go. Find the value of A in the vector. V equals A comma B. So I'm looking for A. It tells me B value is 24. And it tells me the magnitude is 25. Does anybody recognize this Pythagorean triple?
Yeah.
This is one of the more obscure ones.
13, 24, 25?
It's not 13.
11.
And so if we don't recognize it, then let's just pretend like we don't know it. So how could I find A? Well, I know that the magnitude equals the square root of A squared plus B squared. What was the magnitude? 25 equals the square root of A squared plus 24 squared. Is everybody okay with what I'm doing here? Pythagorean theorem. We haven't really done one like this where we're missing a leg. So I thought I better work this out. How could I get A by itself? Well, I need to square both sides. 25 squared is 625 equals squared square roots cancel. That leaves me with A squared plus 24 squared. Move the 24 squared over. So 625 minus 24 squared equals A squared. And that'd be taking a square root of both sides. So A would equal the square root of 625 minus 24 squared, which is going to be 7. It's a 7, 24, 25 Pythagorean triple. All right, dot product. There are two ways we can multiply vectors. One of them is called the dot product. Here's what's important when you do the dot product. Dot product is not a vector answer. It's a scalar. You're just going to get a regular number in the end. So they tell you dot products are sometimes called scalar products. So when you do a dot product, you're just going to get a number as your answer. If you want to make that note somewhere. Dot products are just an answer. So here I've got two vectors. This vector is at 2, 3 in component form. This vector is 4, -6 using the I hat, J hat form. But these are, you see how easy that is? I mean, it's just one form and the other form. There's nothing to it.
You had to double it.
So to get the dot product, here's what we do. We're going to multiply the x parts together. We're going to multiply the y parts together and then combine them. That's all there is to it. So what are my x parts here? 2 and 4. That gives me 8. What's the y components here? 3 and -6. That gives me -18. What is 8 minus 18? -10. That's the dot product. That's why they've got that note at the bottom. It's not 8i minus 18j. Right? This is not your final answer. It's just going to be a number when you do the dot product. So, from here, here's another way we can do the dot product. So again, this is dot product, but say we don't know the component forms. They'll have the last one that told us the x component, the y component, the x component, and the y component. We just multiplied the x's, multiplied the y's, and combined them. Well, what if you don't know the components, but you know the magnitude of the two vectors, and you know the angle between the two vectors? Then you can use this formula. So here's an example of that question. This is still dot product, but you're just given different stuff. I've got a vector v that has a magnitude of 4. I have a vector u. Its magnitude is 7. Do I know anything about their components? No, I just know their overall magnitude. I know these. The angle between the two vectors is 54 degrees. Theta is the angle between them. I have everything I need. I have the magnitudes of two vectors and the angle between them. I can just plug in to find the dot product. So this would be the magnitude of u is 7. The magnitude of v is 4 times cosine of the angle between them. 54. Make sure you're in degrees on your calculator.
What mean 4, 6?
Give me 3 deci's.
16.458.
Degree mode is what you said?
Make sure you're in degree mode because you typed it. Okay, now then, we're going to add, subtract, and do scalar multiplication with vectors. So we're going to show you how this works graphically, and then you're going to probably never graph it again unless they make you do it. So here's an example. If I wanted to add 2, 3, and 4, -1 as vectors, let's see what that looks like. Well, where would my vector 2, 3 be? Well, it'd start at the origin. We would go right 2. We would go up 3. So right here's the vector 2, 3. Is everybody okay with that? Then if I wanted to add the vector 4, -1 to it, I just start a new vector where the first one ended. And if I'm going 4, -1, that means from 2, I'm going to continue 4 more to the right, which would put me here. And then the -1 means I'm going 1 down, which would put me right here.
What? Oh.
So I went from here, I went right 4, I went down 1.
Oh.
I put it at the tail of the previous,
So just
or the end of the previous vector.
The 4.
And so now, to find what I get in the end, if I had a vector that started where the blue one did, but ended where the purple one did, what would be its component form?
6, 2.
I went right 6, I went up 2, which means the component form is 6, 2. So I did that graphically. Does that make sense to you graphically, how we got there? Now, how can you do that algebraically? 2 plus 4.
2 plus 4, 3 plus -1.
3 minus 1. Right? So I get you're not going to do this graphically unless it forces you to. It's just as simple as add the x's, add the y's.
And the x's add the y.
You okay with that?
You go left.
It's going to be the other direction from what it says. Right? So if I go 2, 3, that means I'm going right 2, up 3, which puts me right here, and then 4, -1, but that 4, -1 is being subtracted.
You're gonna go left.
So normally, here, let me show you. 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 4, -1 is normally right here. You agree that's 4, -1? Let's see if I can make this work. Disconnect. Be disconnected. It's not going to. Okay, give me 1 second. Look, now they're disconnected. Look at that. What a joke.
Now you gotta flip that.
Yeah, that's what I'm fixing to get to. Is it okay with this being 4, -1? So when I subtract it, it has to go exactly 180 in the opposite direction. This is not going well. Which means I would go left 4, up 1, right? And then we could tack it on to the end. Yeah, I know. So where do we end up? I'm just going to take about a guess because this has been awful. I'm going to say we're at about -2, 5, but that's just me guessing.
It's -2, 4.
-2, 4. So you see I was close with my graphic. It didn't work out the way I intended. But you're right, it would be at -2, 4. You understand graphically how subtraction works? You go 180 the other way. Scalar multiplication. You just distribute. Graphically, what do you think a 2, if I'm scaling it by 2, is going to do? It's like a stretch. It's a vertical stretch by 2. I'm stretching it by 2. Instead of being at 2, 3, I'm now at 4, 6.
7.
Just like how a 3, 4, 5 would become a 6, 8, 10, right? I mean, same difference. Oh, here we go. What about a half? What's a half going to do? That's going to be a vertical, it's going to be a shrink. compression. 2, 6. What about negative 2? What do you think the negative is going to do?
-2.
Negative is going to
Flip it.
reflect it,
Negative
and then the
one
2 is going to
Stretch it.
stretch it. That's going to be -2, -6. Everybody good? We're still going. I've got 2 vectors. A is 1, -5. B is 0, 3. Find -2A plus 3B. It's as simple as you think it is. It's -2. What's A? 1, -5. Plus 3. What's B? 0, -3. Which one do you think you have to do first? If you were to look at this.
The
-2 at first.
negative 2.
You're going to do the scalar multiplications. Right? I've got to multiply first. That's going to give me -2, 10, plus 0, -9.
Yeah.
Let's go with that.
Oh, and then you get to connect the dots.
And now then I get to -2, 1. I could show you all that graphically, but we saw that didn't go so well. So we understand the premise of what we did. Stretched it, reflected it, put it at the end of one, the start of the other. That's where you'd end up, -2. Okay, here we've got to find the angle between these two vectors. So let's just look graphically at what we're looking at. If I had to go 5i plus 2j, that's this vector, right? Right 5, up 2. 3, -4 would mean I'm going right 3, down 4, which would put me like right here, essentially. Right 3, down 4. Very good. I'm looking for the angle between the vectors. I mean, I'm looking for this angle here. Do you understand graphically what's going on? I'm not ever going to do this using a picture. All right? But that's what's going on. What I'm going to do is I'm going to use this formula for the dot product. If I can find the magnitude of U and the magnitude of V, I know the angle between them is theta, and I can just solve for theta. I also need to know the dot product of this, right? Dot product and their magnitude, and plug in. So let's just start. What is the dot product of U dot V? Do you remember dot product? Multiply the x's. Multiply the y's. Combine them. So the dot product, U dot V, is 7. Equals. How can I find the magnitude of U? Well, the magnitude would just be the distance of this hypotenuse of a right triangle. So this one went right 5 and up 2. So how could I find the magnitude? 5 squared plus 2 squared is 29. That means the magnitude is radical 29.
Wait, how is it? Wait.
U is this vector that has components of 5 and 2. Meaning I went right 5 and up 2.
Which is 29.
Which means the magnitude of this vector is 29. What's the magnitude of this vector? 3, 4, 5.
25.
So the magnitude of V is 25. Sorry. Magnitude of V is 5. Radical 25, which is 5. So you see how I plugged all of those into this formula? The dot product. Everybody good where that came from? The dot product equals the magnitude of U, the magnitude of V, cosine of theta. Everybody's okay with that? Now it's just algebra. We want to get theta by itself. Right now, cosine's being multiplied by this garbage, which means I need to divide by 5 radical 29. So now cosine of theta equals 7 over 5 radical 29. How can I get theta by itself? Inverse cosine. So I get theta equals the inverse cosine of 7 over 5 radical 29. I would put it in degrees unless it just tells me otherwise. Most of the time vectors are in degrees, not in radians.
So we do cosine inverse.
Inverse cosine, yes. Of 7 over 5 radical 29.
It's really 0.9998.
The angle is 1?
I got 74.93.
You're in
I just
radians.
did regular cosine.
Oh, gosh. You got what?
74.932.
Yeah, that looks a little bit.
Yeah, I like that better. I was thinking if the angle of 20s is 1, think how close those are. There's no way we're that far apart with my drawing down there.
Cosine.
A person leaves home and walks 4 miles south.
6 miles south.
4 miles south. And then 6 miles southeast. Because it doesn't tell me, I'm assuming it's directly southeast. Which means, if you think about this with me, if you go directly southeast, what would this angle be? Is it okay with that? If you think about our like Sasquatch problems again, drawing another.
No, I'm not even gonna think about it.
How far from home is she? And what direction must she walk to head directly home? So I need to figure out how far from home is she. Here's where she is. Here is home. So I'm looking for that distance.
Northwest.
Okay, so
And then in which direction? She must walk northwest, but I need to know the angle here that she must return.
Can we not choose the Pythagorean theorem?
You cannot do the Pythagorean theorem. That'd be a great thought
But you
It's
could.
not a right triangle, Jay.
because it's not a right
It's an
triangle.
oblique.
It's an oblique asymptote.
I
135.
wonder, I'm just curious how they are going to want me to do this. When I look at this, I would do the law of cosines right now. Because I know this angle,
135 degrees.
135, because this part has to be 90. This has to be 45.
It's like
So I think that should be 135.
Yeah. This reminds me
Let me go double check how they would do it. Just make sure I'm not just way off.
And we
I
can
mean,
use,
I know this will work, but they may want to see something different.
Yeah, we could use law of cosine because we got side angle
Yes,
sides.
we can use the law of cosines. I'm not doubting that I'm right in what I'm doing, but they may want me to show you something different. And I'm going to just double check.
8 minus 14.
Is this a person leaves home? Yeah.
But if you get all of it, that's
They do it differently.
mine doesn't always change it and it never says.
Mine doesn't say like the next day.
See, mine says 1/115 203.
I'm debating. I'm gonna do it the way they did it. They don't do law of cosines. They do it differently.
Of course they do. They probably use the law of Stimpy.
The law of tangent, probably. They probably made it up just for this problem.
They didn't. Here's what they did. They essentially made two triangles. And they turned their component forms. So look at my red vector. What would be the component form of that vector? If you go, we went right or left nowhere, we went down 4. Right, this is for the red vector. Okay, what about the component form of the blue vector? This one's trickier because I have to go here and here. It's a 45, 45, 90 triangle that we talked about.